Okay, so let us go to the next program. So now I think all of you are comfortable with the flow where you are using the key as a compiler. I'm sure all the versions are installed now. So by using the compiler, we are writing the C program, but then as far as C syntax is concerned, it is same. Only difference is hardware initialization. So I'm just quickly explain about what is the hardware initialization in every program. I might not be explaining every control word, so for that you better refer the data sheet, or else you can refer my videos. I explain in the videos. So for every peripheral, there is a video for. So those videos are there in your folder or they are on the YouTube. So the next task is GPIO pins, general purpose input output pins of ARM Cortex. Yesterday we have initialized as an output port. Today we will see the next experiment is input port. Right? For example, if you want to connect any sensors, so obviously you have to read it's the input. Or if you connect any switches, they are inputs. So when the port will behave like an output, when the port will behave like an input. Right? So we want to see both. So the next example is port C.8. Yesterday you have written a program to make it as an output. So that there the LED is connected, you have made a program to make on and off. So we will be doing the same thing again. Only difference is port A.0, right? Port A.0. There is a switch is there on your ARM Cortex board. Right? There is a switch. So whenever you press the switch, right? Whenever you press the switch, then only that blue LED should be on. If you release the switch, blue LED should be off, or vice versa, whatever. That means it should read the switch. So maybe in future, instead of one switch, you can interface so many switches, so many sensors and whatever. So how to read the ports? So what is hardware initialization here? Hardware initialization means we are using, as you can see, port C, port A port. So that is where the clock of port C, port A is enabled. Right? After that, now if you see port C.8, we are making as an output port. Right? So that is the 16th bit of GPIOC mode register. We are making high so that will become as an output port. After that, you can see port A. Port A, third bit, we are making as a 0 so that we want to make that bit as an input. So port A now is input A.0, port C 0.8 is an output port. That is decided by your always mode register. So AHB enable is a clock and mode register is a direction, whether it is an output or input. Now if you go to the main program, your main program is a while loop. While loop means infinite loop. Always it's a continuously whatever is written in this loop is executing. So what we said is read GPIO A, right? You read this register and with 001 and verify whether it has become 1 or 0. If it is, for example, 1, then in bit you want to set the bit of port C. Otherwise, else you want to reset the bit of the port C. So that means whenever you press the switch, right? If this condition is satisfied, data register you are reading. Data register of the port A you are reading. Yeah, input data register. So if you are reading this register, that too you are interested in the first bit, D0 bit. That's why you are performing the AND operation. AND operation means all other bits will be masked except D0 bit. And you are verifying whether it is 0 or 1. Accordingly, either you have set the bit or reset the bit of the ports. Alright, so execute the program, load the program. There is a switch exactly below the LCD, not outside. Outside switch is a reset switch. It is written on the port. You can see the outside is reset. You press the switch which is exactly below the LCD. That is where port A.0 is connected. Blue color.
In this session, we will see how to use ARM Cortex processor, the design part and interface into wireless access network. ARM Cortex we are using ST microelectronics STM32F051R8 controller, which is a M series F0, which has an inbuilt 32-bit RISC with a memory capacity of 64 kilobytes of flash, 8 kilobytes of RAM, and several peripherals like RPC, timers, ADC, DAC, comparators, and communication is a reasonably good microcontroller for implementing most of the wireless sensor applications because it has rich with peripherals, good for low power applications, at the same time good for high performance applications, being a 32-bit RISC controller. The IC package, as you can see, is a 64-pin LQFP package. Let us see how and what this controller is having. It works on 48 megahertz and operating voltage is around 3.3 volts. Internally it works on 1.8 volts and has serial ports, UART, SPI, I2C and timers and so on. If you look at the architecture of this processor, the supply is somewhere around 2 to 3.6 volts. Internally it works on 1.8 volts as a core voltage. It derives its internal voltage from 1.8 volts. The operating speed is 48 megahertz. That is a master clock. However, you can have an RC clock of low frequency. There is another clock source. Oscillator in, oscillator out, oscillator 32 in, oscillator 32 out. Where here the frequency can be somewhere around 32 megahertz. And the low frequency crystal you can connect 32 kilohertz, which is basically meant for real-time clock. So the clock source is either high frequency crystal, you can connect it here on PF0 and PF pins, or you can connect a low frequency crystal on these OS32 in and OS32 out. So the crystal which you connected, internally it has a phase lock loop so that it will derive whatever is the clock it wants. So the clock is basically programmable. So the clock can be multiplied, the clock can be divided. So the clock is a derived, it's a separate clock source. It derives from the clock external clock which you are connecting. So it is not necessary that if you are operating on 48 megahertz, the crystal has to be 48 megahertz. It's because it internally multiplies also. About the ports, it is very rich in ports. You can see the ports in a sense they are general purpose input-output ports where you can connect LEDs, LCDs, switches, sensors and so on. Of course, digital sensors. The ports, GPIO ports has multiple functions. You can use them as a simple I/O, or you can also use them for special purpose peripherals like ADs, LEDs and so on. So every port line has multiple functions which is programmable. That we will see that we go for the peripheral section. So the ports are named as port A, port B, port C, port D and port F, where port A, port B, port C is having 16 lines and other ports are having less number of lines. So these ports are bidirectional. That means the direction of the port can be programmable with the help of the control ports. Then it has some sensor, touch sensing controller input where you can connect the capacitive type of sensors. And also it has a rich in peripherals. The peripherals are like serial peripheral interface, serial communication interface. So SPI1, SPI2, that is popularly known as MOSI, MISO, SDK, where you can connect the serial peripheral interface, that is master slave, with the synchronous clock, because in SPI you always have a clock, master always use the clock, the slave. So two such type of ports are here. Similarly, you have the asynchronous ports, that is UART1 and UART2, where there is no clock, but then programming is done through baud rate. So extensively we are using these two ports, UART1 and UART2, in order to connect these IoT devices using the The other ports are I2C port, which is a two-wire communication bus. So these are as far as serial ports are concerned. When it comes to analog to digital and digital to analog, so there is a 12-bit analog to digital converter is there. of 16 channels. So you can connect 16 analog inputs. You can convert it to the digital form in 12 bit is the resolution. So the operating speed is programmable. There is an inbuilt temperature sensor is there, which is already connected to the channel of ADC, so that the microcontroller itself can sense the temperature. The DAC is again a 12-bit single channel DAC output is there at the port. So you can convert digital to analog. So very rarely microcontrollers has 12-bit ADC and DAC input. So this is good enough to install the sensor applications because it has 16 channels or 12-bit, the ADC and DAC. And about the timers, it has a good number of timers of very high resolution timers which are meant for timing and counter applications. You can also use it for PWM generation signals. There is an RTC, inbuilt RTC is the real-time clock for calculation, seconds, minutes, hours. There is a CRC, cyclic redundancy check, security features are there, so while communication, you can verify the security part of it. The buses are organized, the internal buses are organized as a AHP bus and APT bus. That means whenever the core, the ARM Cortex core, when it wants to communicate either to the memory section or the peripheral section, the buses are multiplexed, as you can see, bus matrix system. Plus the DMA channels, 5 DMA channels are there. So whenever either the DMA channel or the core, that is ARM Cortex core, wants to communicate to any of the peripherals of memory, you can switch the buses. The buses are two types, AHP and APP. APP is the peripheral bus, advanced peripheral bus, which is meant for mostly the peripherals. AHP bus, that is a high performance bus, and also high performance bus, is basically for data transfer, memory and the CPU. Memory is classified into two, one is the flash and the other is the static RAM. As far as this ARM Cortex 3051 is concerned, 64 kilobytes of 32 bits flash is there and 8 kilobytes of RAM is there. So that is as far as the memory, peripherals, clock generations are concerned. It also has a comparator, so that if you want to compare between the values, you can compare and you can communicate about the status of, for example, like a battery and so on. As far as program is concerned, it implements SWD communication protocol for programming purpose. So the JTAG can be implemented in this ST-Link and debugging tool. So most of the development tools, they support this ST-Link SW communication protocol. The ST port looks like this, where this is where STM 32F0 ARM Cortex processor and connected to the PC by using this JTAG converter. There are two switches out there. One is the reset switch. This one, the blue one, is the user interface switch. And there are LEDs out there, couple of LEDs on the board. There is an LED here, LED 2. LED here, then there is a LED here. So 4 LEDs are there, LED 1, LED 2, LED 3, LED 4. Two switches on the board. And all the ports, you can see port A, port B, port C, port F, all of them are ported on these two connectors that are set on right side, which are total 33 connectors. So these ports we have connected to our wireless sensor network as well as sensor port. Application specific system. Alright, so the purpose of the LEDs, there are 4 LEDs out there on board. The LED1 is a red LED, indicates whether you can only get the power to the USB port, any USB. The red LED will be on. LED2 is a bright light. regular LED indicates whether slow blinking red LED is there or not. That means that pop on before USB initialization. If it is blinking very fast red LED after the first connection communication between the PC and your SD link communication software, which is there very much. And the red LED continuously on means you have established a link between your personal computer and this JTAG. If the green LED is on means after successful target communication initialization, blinking green and red LED is there continuously, both the colors are indicating that means the data transfer or communication is happening. Red LED is on, that means the communication is finished. Orange LED is on, that means it is some problem is there in the system. So communication failure. Orange LED indicates there's a hardware problem. So these LED 1 and LED 2 are connected to both, so there is no way user can use these LEDs. But however, LED 3 and LED 4, they are connected to the IO ports of the IO hardware. So LED 3 is connected to port C, pin number 9, PC 9 of the controller, so that you can program it as per your application requirement. Similarly, LED 4, that is blue LED. The PC 9 LED is green, the blue LED is connected on port C, PC 8. So we will see how to write a program to switch on these LEDs which are connected to port C, PC 8 and port C, PC 9. These are LEDs. There are two switches. One is connected to the reset. So whenever you want to reset the microcontroller, so that it will restart initialization of the program. That is the second LED, the second switch is user defined switch, which is connected to port A PS0. So you can write a program to make port A PS0 to read the switch, whether the switch is pressed. So you can read the data sheet of STM user value when we talk about most of the big functions. As you can see on page number 20, it talks about every big function of this LPFP is assigned to values. So it indicates that the functionality that is main function and alternate function. Alternate function means you can program it in such a way that apart from your simple IO line, general purpose input line, it also has a multiple functions. You can say number of functions for each function. For example, port A PS0 can be a simple input line. It also can be act as an interrupt, so that it also can act as a RPC and so similarly, port A PS1 can see it can be analog input IN1 or it can be a similar function. Serial communication. So PA2 we are mainly using PA2 as you can see is a transmitter PX. That means the IVR is your transmitter pin is connected. At the same time it also uses an ADC channel 3. PA3 is UAR is RX receiver data. So you can use it for communication to receive the data.
Okay, so I think almost all of you are able to do this. That is the program I mentioned, where my port A is input, where there is a blue switch is connected. So whenever the switch is pressed, it is reading the switch, and then port C.8 is output, so that where the LED is connected. So that it depends on the conditional statement. Whenever the switch is pressed, LED is getting on, switch is released, LED is getting off. Okay, that is just a simple GPIO pins. How to configure them as an output or how to configure them as an input. But let me tell you, most of the applications requires GPIO. Whether you connect LEDs, LCDs, switches, sensors, stepper motors, DC motors, actuators, almost all these kind of applications require GPIO. That means if you know only this much program, your 90% of the practicals can be done. 90% of the projects can be done. Okay. Anyhow, that is just to know about GPIO. Now let us go to the little bit complicated programs. Complicated programs means now how to write a program for LCD. There is a LCD on your PCB. LCD is not simple. LCD itself is a microcontroller based system. As you can see, it is a 16-pin connector on the LCD, and LCD is mounted with some controller. There is a LCD controller, there is a RAM LCD has. Unless you initialize the LCD, it won't work. So LCD is external, right? LCD has its own control boards where they need to be programmed. LCDs are two types, graphics LCDs and text LCDs. We are using now the text LCD, not graphics LCD. Text LCD means you can display character by character. How many characters you can display on LCD? The one which you have? 16 characters, right? If you count the number of black matrix, you will find 16 characters. How many rows are there? 2 rows. So this LCD is called 16 by 2 LCD. You will get 16 by 40 also, right? 16 by 4 also, 40 by 2, 40 by 4 also. So LCDs are different sizes. Graphics LCD is totally different. Graphics LCD means pixel by pixel you can program. Pixel by pixel you can make it on, make it off. Whatever is the graphs you want to plot it, waveforms, whatever you can do that. But in text LCD, it accepts only ASCII characters, remember. Whatever you want to display, the equivalent ASCII value, if you give it, then only it will display. Okay, including the space. Space is also ASCII character. Okay, so what is the difference between control words and the data? Right? Control words for LCD means you want to blink the cursor, you want to increase the size of the character, right? Or you want to clear the LCD, right? So these are called control words for the LCD. Data means the value which you want to display. But remember, both of them are in ASCII value. Both of them are hexa numbers. Then how the LCD differentiate between the control word and data? For example, I sent 30. 30 can be control word, 30 can be data. Right? If you want to display 0, then you have to give 30. But 30 is the control word to initialize the LCD. So how the LCD differentiate, whatever you are sending is a data or control word. So that is why LCD has some control signals. The first 3 control signals are called RS, read optic write bar, and enable. So these control signals differentiate that whenever RS is equal to 0, it knows that you are sending control word. Whenever RS is equal to 1, that means you are sending the data. So that is why if you see the number of pins on LCD, there are 16 pins out there. You can see the soldered part. There are 16 pins. Out of those 16 pins, first is ground, second is VCC, third we are adjusting the contrast. Then after that, the 4th, 5th, 6th is RS, read optic write bar, enable. These are called handshake signals or control signals. After that, 7th pin onwards, data, D0 to D7, 8-bit data bus. Right? So that means we have completed 14 pins. And then finally again VCC, again ground. Last VCC and ground is for that yellow LED which is on your LCD. Right? Without yellow LED also you can use the LCD. But then what happens? Night time you cannot see what is displayed on the LCD. So that is why the backlit LED also you want to make it on. So that means 2 VCCs, 2 grounds, 1 contrast adjustment, RS read optic write bar, enable, D0 to D7. So now if you want to connect LCD to microcontroller, how many pins are required? you want to interface LCD to microcontroller, how many bits are required? Control bits and data bits. Okay, total how many? 8 plus 3, 11. So 11 I/O lines. 11 I/O lines. You have to connect it to the microcontroller so that you can program it. But LCD has one more way of interfacing. Remember, if you do not have 11 lines, by 7 lines also you can connect the LCD. Remember. So by using 4 data lines also you can connect. D0 to D3 you can omit. Right? Only D4 to D7 if you connect it, then that is called 4-bit mode LCD. You can connect the LCD either in 4-bit mode or 8-bit mode. In 4-bit mode if you connect it, advantage is you have saved 4 lines. So 4 plus 3, only 7 lines are required to connect the LCD to microcontroller. Okay, so now you can open the third program where LCD program is there. I'll just quickly explain what are the functions are there of initialization of the LCD and displaying the data on the LCD. Okay, so this is the LCD program. Okay, so if you quickly see the program, we have initialized the LCD. LCD function we are calling because all the functions are written in LCD.C. So not necessary that like if you are a good C programmer, you all know not necessarily that whole program has to be in one file. You can create multiple files so that you can call the functions from one file to other file. All LCD programs you put it in one file and delay program some other file, main program can be other file. So that when the compiler compiles these programs, first it creates the object files. Right? So all the object files will be linked by the linker and then finally one single binary file will be created. So that is why if you are a good programmer, then you should know how to segregate the programs into different files and then all those functions. So we are calling this LCD initialization program, and once the LCD is initialized, assume that it is initialized. I know at least I require half a day to explain about the control words of LCD. Assume that okay, now you have read the data sheet of LCD and those control words you are given. So let us assume that function is given. After that, whatever you want to display on LCD, there is another function called LCD puts. So if you use this function, whatever you put between the quotes, right, that text is converted into ASCII value and it will be displayed on LCD. Now how many characters you can give between the two quotes? 16 characters. Because one line is 16 characters. So that means even the space is also considered as a character. So total 16 characters. Now look at the another function of LCD, that is called LCD go to XY. This is specifies the coordinates of the LCD, right? For example, 1, 4. That means this will tell us your row number and this will tell your column number. How many columns are there? 16 columns are there. How many rows are there? 2 rows are there. So that means if this is 0, if you say LCD go to XY 0, so you want to display on the first line. If you say 1, so you want to display on second line. Now this, whether you want to display from first column or maybe fourth column, middle and whatever, you can play with this number. In LCD, there is no control word to move the characters from left to right and right to left. But still you can get that effect. Still you can do that moving character effect. How to do that? How to do that? By looping this. You just play with this number from 0 to 15, then your character will be moving. Just try to understand whether it is a graphics LCD or text LCD. Basically, they are memory locations. They are memory locations. LCD has a memory. Even your display card is a memory. So whatever is this characters, actually they are written to a 16 memory locations. So total 32 memory locations are there. For first line, 16 locations. Second line, 16 locations. Now those memory locations address is specified by this. Okay, then you are moving the data from one memory location to other memory location. Then the LCD is blindly reading the memory locations and displaying on the LCD. So that means it is just moving the data from one location to other location. Same thing happens in graphics LCD also. It is made up of pixels, lot of memory is there. So then whatever you write into that memory location will be displayed on the LCD. So just you are addressing the memory location and moving the data from one location to other location. Okay, so that is how you can display the text on the LCD, and the position where you want to display is also specified by this control board. And anyhow, this is a repeated program again. In the while loop, your LED blinking program is there. Just to see LED is also blinking. So this program, one side your previous program to flash that LED, but most importantly you want to display this string on this screen, on the LCD. So I want to see, I will give you 15 minutes time. Just can you try to do something else, whatever is given on your LCD, like as I said, moving, if you are a good C programmer. See, remember now, once, just let me finish. So once I have initialized the LCD, once I am giving this function to display the string, once I am positioning my character, whatever you write, rest of the thing is a C program. It has nothing to do with either the ARM Cortex or to the LCD or to any other hardware initialization. If you are a good C programmer, I am asking you, why don't you display time on your LCD, seconds, minutes, hours, display the data, moving effects, whatever, flash, whatever, all of them are playing with the numbers. That's all. Rest are all done. We have already taken care of hardware initialization. Right? So try yourself.
At the same time, it also uses the ADC plus other functions in there. So like that, every bit has a, like PF4 is a DAC. So there is only one single channel DAC is there. That is called APF, which is the bit activity of the microcontroller. It is connected on your out of those 33 pixels connected on P1 connector on pin number 30. So as an interface point of view, you should look here on which pin it is available. As far as microcontroller is concerned, it is there on pin number 20. As far as both functions are concerned, it comes under PF4 as a GPI. But at the same time, it has a multiple functions, 6, 7 functions are there, which is a program. So like that, one should go through about the microcontroller pin functions, where you get ADC, DAC, timers, interrupts, and the serial communication groups like ERD, I2C, serial and so on. This data sheet will indicate the pins and their functionality and on which connector they are available, so that when you interface, let's say for example, see where SPI is available on PSCL, MISY, MISL, and I2C is available on PB7, that is SDA, SCL, and so on. So based on your application requirement, functionality of this information, so the microcontroller pins are available on which line, that's which connector, and how they can be configured, where you can get the functionality and some of the pins are supply pins and so the character for this, as you can see, there is a left side character which is called P1, the right side is P2. So pin number 3 is battery. Other pins are like port A, port B, port C, port F. They are available on the pins. Similarly, on P2 connector is 33 header line, where pin number 1 is 5 volts, pin number 2 is ground, and so on. So one can refer the pin connections accordingly and connect your sensor to wireless communication device from the data sheet of the STM board. Now let us study more about the controller and the control boards. So as we have already discussed about the system architecture, there are two DMA channels or the CPU can access the buses. So the buses are either high-speed buses, that is AHP bus, high performance buses, or peripheral buses, advanced peripheral buses, where most of the peripherals are connected to APP bus. So this bridge will convert from AHP bus into APP bus, so that when it comes to memory, then you can transfer the data to memory first. When it comes to peripherals, most of the peripherals doesn't work the same speed of the controller, so they are connected to those buses. The ports, as we have discussed, there is A port, B port, C port, D port. Let us study for the memory organization. STM, the memory interface for this controller, as you can notice, starting from 8 zeros and ending with 8 Fs, that is total 32 address lines. So it can address 2 raised to 32, that is 4 gigabytes of memory space. So the memory, if you carefully look at, it's not just a memory, it also has a peripherals. So that means ARM Cortex doesn't differentiate between peripherals and memory. The both peripherals and memory comes under the same memory mapping. It follows linear gradient format. That means the lowest number byte in a word is considered as the word's least byte, and the highest number byte is the most significant byte. How it is organized? If you see, for example, the starting address of E000 and 40 comes under peripherals Cortex M0. Similarly, static RAM is starting from 200 onwards, and the flash memory is starting from, including the boot memory, code memory is starting from 000. The first location is your boot static RAM flash memory. And also there is a flash memory at 0800. And the peripherals which are working on APP bus, AHP bus, AHP bus, they have a reserved space, peripheral space. So each peripheral has its own address. For example, GPI would A, GPI would B, C, you can see the address is given. So that means whenever you want to initialize the peripherals for input or output purpose, or whenever you want to write the data, or whenever you want to read the data, you are supposed to use these address lines of A0 to A31. So it uses 32 address lines for addressing either the memory or the peripherals. So this is the memory space which is reserved for the peripherals as well as the flash memory of the controller. So some of the memory, as you can see, it is reserved for the next generation of the ARM processors, including the peripherals like CAN, UART, I2C, all of them have a reserved memory space of around 1 kilobytes to 2 kilobytes of memory space. This is reserved because storage 32 is huge, 4 gigabytes is huge range, so they are reserved the space, extensive space for these peripherals as well as memory space. Some memory is already integrated, it's like 8 kilobytes of static RAM is there at 2000 onwards, and some memory space is reserved for future expansion purpose. Before going more details about the ARM Cortex processor in terms of internal architecture and its peripherals, let us see how we have used these features like the I/O ports, the UART, and the A to D converter, DAC, for our application. So we have our wireless sensor board, as we have discussed in the past. That is WSN board requires EXE DXT, which is coming, which is a multiplex by select lines, multiplex one, which is connected to the DXT pin of these Wi-Fi using Bluetooth and GSM, and RXT is also coming from the same multiplex. So we have discussed how this multiplexing is done by using 7.5 tri-state. So we require UART in order to connect these ports. Similarly, we also require 4 select lines, that is GPIO lines, so that these GPIO lines will make this tri-state enable or disable. So whenever this select line is 0, that means this RXT signal is connected to RXT pin of the GSM. Whenever select line 3 is enabled, that is 0, and other bits are high, that means this RXT pin of the microcontroller is connected to RXT pin of the Bluetooth device. So that means in short, the multiplexing is done by using these 4 select lines, and in order to communicate through serial programming protocol, DXT RXT lines are expected from the ARM Cortex processor. There are some other signals out there like ring indication, PWR signals for the GSM and key for the Bluetooth. So this 5x2 can be connected, the basic connector which is there on the communication port, we will connect it to the ARM Cortex node for UART and GPIO lines. So let us see on ARM Cortex where these signals are connected. So if you can see Cortex code, again the basic connector is there, but however here the signal of here DXT pin is connected here port A, PN3. So PN3 is where is PN3? PN3 is here on pin number 18 of your P1 connector. So what is PN3 on your microcontroller is, if you refer the data sheet, so alternate function of PA3 is RXP. That means your microcontroller PA3, which is RXP, is connected to the your communication device DXT pin. So whenever the IoT or any communication module wants to transmit the data will be received by your ARM Cortex code, the PA3 pin that is the receiver. Similarly, PA2 of the ARM Cortex act as a transmitter, and other ports where we have connected the select lines, that is select line 1 is connected to PC2, select line 2 is connected to PC3, select line 3 is connected to PC4, select line 4 is connected to PC5. So when you write the program, you have to make sure PA2 and PA3 act as a UART or communication, and PC2, PC3, PC4 and PC5 use them as a simple GPIO, so that whichever is the communication you select, you have to make a specific pin as a 0 and all other pins act as an active line, so that particular communication
important programs is LCD is an external peripheral. It's not part of ARM Cortex. Actually, we have interface. It is a choice. Nowadays, we get even touch screens also if you want to interface. So, this is an option. Now, let us go to the next program. That is how to program the serial port, the most important as far as our communication is concerned, serial port of the ARM Cortex. So that through that serial port, you can connect ZigBee, GSM, GPS. Yesterday, we have connected all these communication devices to computers USB. Today, we want to connect all these devices to ARM Cortex. Okay, to serial port. So before connecting these wireless communication modules, first let us write a program whether serial port of your ARM Cortex is working or not. So through serial port, we transmit some data, and now where you will display the data? If ARM Cortex through serial port, if it is transmitting, where will you display it? Where will you display it? It is transmitting serially. Where will you display it? No, I have given only one microcontroller to you now. So now what is the option? The option is your computer has, yesterday we have done, USB to UART converter. Right? So your microcontroller, if it is sending the data, you should display it on computer's terminal. Right? So which software you use it to display the data?
Real terminal.
Either real terminal or flash logic. Using those softwares, you have to display the data. Okay. Now, where is the serial port on your ARM Cortex board? The serial port is there. There is one more USB connector below the LCD. That is the serial port of your board. Remember. Okay. So again, we have converted serial to USB there. USB to UART conversion we have done. I will show you, I will demonstrate what I am doing. You do the same thing. So now for this practical, you require two USBs. So take maybe from your friends, wherever they are free. You require two USB cables. One USB cable is for programming the ARM Cortex. Right? That you have already done. Right now you are already doing that. But second USB cable is to convert serial to USB. Right? So connect to serial, all of you connect to serial to USB. Connect it and tell me what is the serial port number it has assigned. You should know that number is a unique. So connect the serial to USB converter cable to your second USB port of your PC. Where will you find out the number? Where will you find out that number? Device manager. So go to device manager, check what is the serial port number it has assigned. That is unique. It won't be saved.
This serial.
USB cables. One for this, other is for serial. Anybody wants cable? Anyone need cables? All of you have two cables. One for programming, other for data transfer. Try to understand. Program is different, data is different. Program is different, data is different. Program we are doing through STU-Link. Programming the flash memory of the microcontroller we are doing through STU-Link software. But the data transfer of the microcontroller we are seeing through either flash magic or real time. So data transfer is happening through serial port. That is why go to device manager and find out what is the virtual serial port number. It has a dynamically assigned. Every PC has a different number. So that's why find out the number. All of you got the number? You have connect to the serial port of the ARM Cortex board, not yesterday's communication board. ARM Cortex programming, ARM Cortex data. Done? Okay, now I will show you what will happen if you load the program, and then you can modify the program. Okay, so where is the program? The program is go to project, open project. So the program which we are talking is serial, 6th program. Okay. See, there are other programs related to ADC, DAC, all these things that will be useful when you have, like CRO, all those things, then you can display those waveforms. So let us not bother about other peripherals. Go to the 6th program. So in 6th program, if you see the main, this is also interesting because here also we are using ADC program. But then if you see, you are saying UART puts. So UART puts means instead of displaying on LCD, anyway LCD is there, that is okay, that we have already done. But in while loop, what we are saying is UART puts, and then whatever you put in the ports is transmitting through serial port. So the LCD UART initialization and all is taken care. That is done in your UART-C. There complete UART protocol, baud rate initialization, whatever we have done yesterday, that is done. Okay, so now if you load this program, so go to file, open file, your 6th program, in install folder, serial.txt file. If I say program, target and program. Okay, I have loaded the program. You also must have loaded the program. But where to see the results? Because it is transmitting. It is continuously, as per your program, the while loop is continuously transmitting this result. So what you should do is, like I said, go to device manager, see what is the port number it has assigned. So now in my case it is 12, in your case it may be something different. So data is coming through this serial port. Alright? Okay, now I will minimize this. Okay, so now I will go to my, if you have installed Flash Magic or Real Terminal, whatever yesterday, go to, I am opening my terminal. In my case it is COM12, baud rate is 9600. If I say OK, now you can see it is displaying UART test. Okay, so who is sending this? Microcontroller through serial port. And you are reading through serial port of your computer and displaying on the monitor. modify this text, display something else on your screen. Okay. If you are interested in knowing more functions of the serial port, you can always refer this uart.c, where we have initialized the serial port. Lot of functions are there. UART initialization, where we initialize all the control words of the serial port. Put string, right? You can see the put string function of UART. So all those functions are written in this file. Then we are calling those functions. So that is why you will see every program, there is a tremendous scope of contribution. You can also create your own functions, you can also create your own libraries as per your requirement. And those functions can be called. That is how when students, faculty are contributing in terms of developing their own libraries for these controllers and those communication devices. Cable. $9,600. Okay, so you should display different string on the screen. Modify the program, display different text on the screen. So that means you are able to transmit the data serially to the PC. This is the most important program because all communication devices, Bluetooth, Zigbee, GSM, GPS, Wi-Fi, all of them are using serial port, UART. In my videos I explained at least one semester you can conduct the practicals on this. Those many examples are there. But just quickly to see, I will demonstrate one program, then you can try yourself. Okay? So that is, whatever right now we are displaying on computer monitor, that I want to display it on your mobile phone by using Bluetooth. Alright? Yesterday we have done by using Wi-Fi, PC to mobile phone. Today we are using ARM Cortex to mobile, not PC. Okay? So how to do this? I will demonstrate, then you can try yourself. Make sure all of your communication ports are off. Don't switch on those communication ports. I will show you, then you can try yourself. So the next program is, assume that there is a temperature sensor is there. Right? Generally, when we give these boards, we also have some sensor boards. Right? There are some sensor boards out there where we connect temperature sensors, radiation, optical, and so on, magnetic and so on. So if you connect these boards, then there is a ADC program is there. It will read the data from those sensors and it will communicate. So right now you have connected the sensor, then some random value should pick up and display. So that data you want to display it on your mobile phone. Whatever the data is coming by using Bluetooth. Similarly, we see by using Wi-Fi and all how to do that. So the program, you can first refer the program, go to project, open project. The program is Bluetooth, program number 9. As I said, it is really interesting for computer and IT students also, these kind of examples, because there are a lot of things related to operating system. Right? We actually, electronic students, for them it's a new subject. We have to teach at least a couple of topics about operating system. Otherwise, for computer and IT, operating system is there. If we see the 8th program is about how to create a file. Okay, how to create a file in a flash. If you have a flash card, you can see in your ARM Cortex boards, right? In ARM Cortex board, there is a provision for connecting flash card. If you have a SD flash card, 4 GB, 8 GB, whatever, you can put the card into that. This is what we are talking about, data acquisition. Means you can create the file and you can open the file. You can write the data into the file. So that means you should know how to create a FAT32. The way operating system creates a file in a hard disk or a flash memory, pen drive. Similarly, we should write a C program in embedded C to create a file in flash memory, open the file, write the data, close the file. Means related to file allocation table, FAT32 format, operating system. These are all really interesting topics where I said it's not just electronics or it's not just a software or a computer branch. It is a combination of both. And lot of other applications are also there related to power electronics, biomedical and so on. Alright. So now I am not talking about operating system and all. Let us go to the 9th program, which is a Bluetooth. So in this Bluetooth program, there is no much difference. Just now whatever we did is the same. That is, we want to transmit a string, but then along with the string, we also want to transmit the data. Okay, so if you see, what we are saying is that we are not only saying temperature as a string, but we also want to, whatever is the data is there, the data also we want to transmit, which is there in the buffer. So the buffer is nothing but the A to D converter is acquiring the data. That data we want to transmit. And oblique and oblique are next line and carriage written at 9 feet. So that every time the next line it will display. So assume that your Bluetooth is not connected. Now right now don't switch on none of your communication boards. Just execute this program. When you execute this program, since we are transmitting through UART1 as well as UART2. Remember, here now we are using 2 serial ports of the ARM Cortex. Same data I am sending to 2 serial ports. One is UART1, second is UART2. UART1, where right now we are connected to computer serial port. UART2, we will do it later on, where we will connect a Bluetooth. So then you will notice the data is displayed on computer monitor also and your mobile phones. So right now, don't use your mobile phones and that Bluetooth module. See what is displayed on computer monitor. So I am loading the Bluetooth program. Okay, I have loaded. Now you see it is displaying temperature of the some sensor, some numbers, some hexa numbers. Because right now we are not connected any module. If I connect the module, then A to D converter value will come. So is it displaying on your computer monitors? Right? All of you? Okay. Now we are supposed to connect a Bluetooth on UART2. So I have already connected, at least my Bluetooth is on, all your other Bluetooths are off. Okay. I will pair it through my mobile phone, then you try yourself. Okay, so I am switching on my Bluetooth of my mobile phone. I don't know if by any chance you are downloaded or not. There is an app called Blue Terminal. See, if you want to display the serial data. See, Bluetooth has a different profiles. Right now we are using a profile which is the serial data. You have the serial data that I want to display it on the mobile phone. So further there is an app called BLUETERL, Blue Terminal. It is a free, you can download it. Now when I search the currently available Bluetooth modules, it is saying HC05. Remember this Bluetooth terminal, the brand name is HC05. Now here the number, no, somebody has switched on Bluetooth. Okay, some DD is switched on. Okay, anyhow, it's indicating. Anyhow, why I didn't ask you to switch on your Bluetooth modules is every Bluetooth has a unique number. Now you will be confused to whose Bluetooth you are pairing. So So you should know the number. So I know my module number, I believe it is E2. Yeah, indeed, my number is E2. Now it is paid. Can you see it is displaying the data? Okay. So and so. So whatever it is displaying there, same data will come on my mobile phone. Okay, this. Right? Okay, so now what you can do, how to connect it? First, do you have Blue Terminal by any chance? If you have internet, download the app, BLUTAR, Blue Terminal. Otherwise also, just verify whether this Bluetooth is recognized by your, at least your mobile software, whatever is the software in your mobile phone, through Android. Okay, so now how to do this? Yesterday, whatever you have done, connect the board, your communication board, give the power supply to that. Now I will give you one FRC cable because you want to connect your microcontroller to the ARM Cortex, it's a communication port. But when you connect it, what is the rule? The rule is all the switches should be off. The reason is, yesterday we are switching on the switches because through computer's USB port we cannot select the devices. But today through microcontroller I can select because microcontroller has GPIO lines. USB doesn't have GPIO lines. So that is why when you are connecting to the microcontroller and selecting this GSM, GPS, whatever, make sure all the switches are in off because selection is done by my program. In my program, I am selecting which module I want to program. So carefully, if you see your C code, there you select it first, that which module you want to program. Right? Can you see the select lines? These are the select lines. So if you want to select a Bluetooth terminal, whether you want to connect Zigbee or Wi-Fi or GPS, whatever, that we are doing through program. That's what I explained in my videos. There are select lines are there. So take the FRC cable, keep all the switches are off, then connect the FRC cable on your communication board. Then the other end of the FRC cable on your ARM Cortex board, there is something called WSN is written. Connect there. WSN. Right? Now we have connected serial ports of the ARM Cortex to all your Zigbee, GSM and so on. Right? So this port should connect to this. WSN is written. Okay, so if you want to see the results, WSN. If you want to see the results, then your mobile should have that blue Bluetooth app. Or else just, but now there will be a confusion now. That what is the Bluetooth number? Tell all your friends to switch off their whatever number is of the number. Or you just pair others, then their data will be displayed on. No. Now selection is done through microcontroller. That's what I am saying. In the program, we are already doing this. If you see how to select it, that we are doing in the program to select lines. If you want to pair, I will switch off my mobile. My number is E2. If you want to pair, you can pair my Bluetooth terminal. Then you can display the data. E2 is the last 2 digits is E2. But at a time only one fellow can pair, other has to disconnect. Okay, so I think we have another 15-20 minutes. What we should do is, I will explain 2 more programs. Simultaneously, those who are finished up, those who doesn't have blue terminal software, you try other 2. The other 2 is, there are 2 programs which are related to GSM and Wi-Fi. I will demonstrate these programs so that we can try those programs also. So what I will do is, I will demonstrate Wi-Fi program. Through microcontroller, I want to enable my Wi-Fi. Now what happens is, I will make use of my mobile as a router. The mobile will act as a router. I give the username and password of my router to ARM Cortex CPU. Then it will pair. Since my mobile has the internet enabled, then I will pass some Google server hyperlink along with some data. The data is longitude and latitude. So now this fellow will connect it to the Google server. Whatever the Google maps about the information of whatever is the longitude, latitude I am giving, from the server it will extract that where currently I am located. So that data is supposed to be bring it back and display it on your computer monitor. So I will do that. So the program, I am talking about Wi-Fi. Is it clear about the Bluetooth? So just you should have a Bluetooth software, terminal software, and data will be displayed on your mobile phone. So I am loading my, another example is Wi-Fi, example number 11. Right now, can you see, it's very interesting. Yesterday, whatever we have done, 80 programs, 80 commands program for various modules. Now today you are supposed to do it through embedded C program. See, do you remember 80 plus EIP send and all that stuff yesterday you did it? That you have to do it through C program. Okay, all those commands which are relevant for your Wi-Fi, whatever to be enabled. That's what we are doing. Can you see your CIP marks and so on, CWJIP, all those stuff. So you should be a good C programmer and you should very much conversant with the mainly string, sending a string, receiving a string, comparing a string. Because when you want to compare the password and all, no, then you should compare character by character. Then unwanted character you should be able to segregate whenever you get some data. So that is why you should be a very good C programmer. Rest of are all just a hardware initialization, nothing special about it. Okay, now if you see the hyperlink I was telling, the API. This is what on Google Maps, right? Now we are supposed to send this, right? The link, the Google Map. Then whatever you say, and of course the IP address, Google API IP address. Now here what we are doing is, so from that link, you can see I am passing some parameters, latitude and longitude. So this latitude, longitude I am passing to that Google Map. There I will extract the data I want to display. I am sure every mobile has a Wi-Fi. If you have internet in your mobile phone, now execute this program and you create a hotspot and give the username and password. This Wi-Fi will pair it to your mobile as a router, and then since you are passing this information, it will get back the location and should display in the screen. I will try with my mobile phone, you try with your mobile phone. I am creating hotspot on my mobile phone. Similarly, you can do it with your mobile phones. Okay, so procedure is same, absolutely there is no difference. Only thing is, in the previous program, on your computer monitor, right, some data is displayed, is getting displayed. But in this program, once you load the program, it will ask you, please give me username and password on your mobile router. It is bidirectional communication now. So you should give the username and password. And if it matches, if it pairs, then it will extract the data from the Google server and display it here. So a complete procedure is same, only thing is now you have to give username and password. Don't change any of the settings. Your terminal, everything is same. See, I have loaded my program. First this should come. Wi-Fi test or something. The new program is loaded. If Wi-Fi is working fine, right, if everything is fine, then it will ask the username and password. If it asks the pin number of the Bluetooth, the password for Bluetooth is always 1234. Whenever it asks me the password, 1234 by default. You change it, but by default password is 1234. नहीं अभी validate